Hello everyone, as you all know, I'm Mr. Prashant Kumar Singh. Today what we are going to do, that is called trigonometrical identities. What I told you in my last videos, I'm going to start trigonometry part 2, where I will teach you all like trigonometrical identity, which is also useful for A-Lebel IB, IGCSE and even for CBSE ICSE. So here I'm just going to start trigonometrical identity. Last class also, our last video, what I told you, there is so many formula and we are going to use that all formulas. So here I'm going to show you all, like basically you all knows here, like trigonometrical identity first formula is like sine square theta plus cos square theta is equal to what? 1. So here sine square theta plus cos square theta is 1. So from here we can write also sine square theta is equal to 1 minus cos square theta. Then you can write cos square theta is equal to 1 minus sine square theta. Alright, now if you know these all, this is the first. Then second identity is here, that is very important, is here. These people also write sec square theta minus tan square theta is equal to 1, or you can say just like replacing the place, sec square theta is equal to tan square theta. Now if you already know this till here, then you can also say here tan square theta is equal to sec square theta minus 1. Now the third identity, which is very popular, is here, like this is the relation between cosec and cot. So you can say 1 plus cot square theta is equal to cosec square theta, or generally it's memorized like that, cosec square theta minus cot square theta is equal to 1. So you can say 1 plus cot square theta, cot is going that side, so 1 plus cot square theta is equal to cosec square theta. Alright, now you can say here 1 plus, then cosec square theta minus 1, cosec square theta minus 1 is equal to cot square theta. So this is just replacing what is your requirement. According to that you can use the formula. Suppose you have somewhere cosec square theta and you want to write in cot, so you'll be write 1 plus cot square theta. Somewhere you have like cos square theta and you want to write in terms of sine, so cos square theta is equal to 1 minus sine square theta. And this is what tan theta is, sine theta over cos theta, and you know tan is the reciprocal of what? Cot, or cot is the reciprocal of tan. So if tan theta is sine theta over cos theta, so cot theta will be cos theta over sine theta. Okay, fine. Now this is also a very important here formula, that is called, like there is a 4 quadrant in trigonometry. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So as you all knows, for this, you know, like all student take calculus. So this is very important part. In first quadrant, all trigonometrical ratios like sine, cos and tan is positive. In second quadrant, sine is positive, cos and tan is negative. In third quadrant, tan is positive but sine and cos is negative, and in fourth quadrant, cos is positive and sine and tan is negative. And this is going to work like, you know, like just like here would be theta, here would be 180 minus theta, 180 plus theta, and 360 minus theta, or you can say in radian form, this would be theta radian, and this is pi minus theta, this is pi plus theta, and this is 2 pi minus theta. Alright, so this is, suppose you want to find sine 40 degree. So sine 40 degree is equal to, you can write sine 40 is equal to cos 90 minus 40 is equal to cos 50 degree. Alright, so this is generally useful. Sometimes they ask a question here and we have to use to solve that, and is really important to know. Alright, now you know, as usual, like sec is the reciprocal of cosec, so sec theta is equal to 1 over cos theta, and cos theta is 1 over sec theta. Similarly, cosec theta is 1 over sine theta, then sin theta is 1 over cosec theta, cot theta is 1 over tan theta is 1 over cot theta, and these all formulas you know. So this is that all trigonometrical identity. Before starting the question, we have to know there is a double angle also. That topic I will also explain in my next videos, so you all have to wait for that. And there is a double angle, then how to do like sin A plus B, then cos A plus B, derive the formula, and how to implement to find the double angle and everything. Okay, by the way, you all have to understand till here, and this is the things. And now I'm going to do some example for trigonometrical identity, so you all have to see here. Like see here, like the first thing what we are going to do is about here. Okay, so let me go back, sorry, like clear the screen. So here, clear all. Now here I'm just going to the photo library, I'm just getting some like proving things, and here. Okay, so you all can see here some question we have, and we are going to do. All right, so here, so look here, like yeah, here we have the first question what we have to do by proving. So we are going to do here, and look here, the first question is here, cos x minus sin x. So generally for this kind of proving we have to do like whatever we can. So we are going to do here like left hand side, take here left hand side, and we have to prove right hand side. So left hand side here, like we have cos x minus sin x and whole square. So you know, as you know, like a minus b whole square, so that formula will be used. So you know very well, this will be changed into cos square x, this will be changed into sin square x minus 2 cos x into sin x. Alright, so as you know, this is like sin square x minus cos square x is equal to what? 1. So this total value is going to be what? 1, right? So 1, this is 1, and then we have here already like 1 minus 2. You can write in a order what they have for proof, sin x into cos x. So this is the formula. Finally we got right hand side 1 minus 2 sin x into cos x, and this is your right hand side. So you got proved. This is the first question is done. Now we are going to do like question number 2. Question number 2 is here, like we have the left hand side, and we are going to use the left hand side, and with the help of left hand side we are going to do right hand side. So take here left hand side. Left hand side is equal to, we have here tan x plus sec x. So as you all know, in last page I already show you all, tan in terms of sin and cos is what term? Tan will be like sin x over cos x, and sec will be also what term? 1 over cos x. Alright, so we are going to do here like total LCM is what here? Term cos x. So you know very well, like this will be changed into sin x plus 1. Alright, so now if you already know till here, now we have to get denominator 1 minus sin x. So this is a clue like how to do it. So you can write here 1 plus sin x, and then we have to multiply numerator and denominator over what term? 1 minus sin x according to our requirement of the right hand side. So here we are going to write 1 minus sin x, and cos x already we have. So this is the additional parts what I did it here. This portion and this portion will multiply up and down, so there is no changing, but our requirement to do it, that's why. So now you know a plus b, a minus b is a square minus b square. I am implementing that formula here, and I am going to get here 1 square minus sin square x over cos x 1 minus sine x. So as you know, 1 minus sine square x, so this is going to be like 1 minus sine square x over here cos x, 1 minus here 1 minus sine x. Okay, 1 minus sine square x is equal to cos square x over cos x, 1 minus sine x. 1 cos cancel by here, so finally we got to prove here what the right hand side, that is what, cos x over 1 minus sine x. So this is your right hand side and you got the proof. Alright, so if you already understood till here, so now I'm going to go on question number 3. Question number 3 is here, guys. Look, 1 over, we have here 1 over, so I can take here direct the LCM from left hand side. So basically let me start here the question number 3, so we'll get more space to do the work. So question number 3, here we have 1 over 1 minus cos x plus 1 over 1 plus cos x. So total LCM we are going to get here 1 minus cos x and 1 plus cos x. Okay guys, so you all knows here the denominators we have to make same, so multiply here up and down, here and here by 1 plus cos x and here by 1 minus cos x. So practically we are going to get here 1 plus cos x plus 1 minus cos x. As you all know, this plus and minus got cancelled, so we are going to get here like this and this got cancelled, so we are going to get here like 1 plus 1 is 2, so here is 2 over 1 minus cos x and here 1 plus cos x 2. So you are going to use here 1 minus sin x, 1 minus cos x, sorry, and 1 plus cos x. This is sum and difference formula, so it's going to be 1 minus cos square x. So finally you are going to get here 2 over 1 minus cos square x is what term? Sin square x. Alright, so this is you got like sin square x, then you can write here 2 into 1 over sin square x is equal to 2, and 1 over sin square x we can write here cosec square x, or people say that 2 CSE square x. You all have to know CSE x is equal to cosec x. So if I will do here square, so that will be also square. So don't be confused, this meaning and that meaning is practically same. So this is the meaning what you all have to know, and this is our third question has done. Now I'm moving for fourth question. So you all can see here in my next page, I'm going to show you all the fourth question. So here, see, the fourth question is going to be here like, guys, see, sec x plus 1 over tan x. So I'm going to write here like left hand side for fourth question is sec x plus 1 divided by what? The tan x. This is our question, and I want to prove the right hand side is sin x over 1 minus cos x. So sometime we have to show sincerely the right hand side, what is our demand and requirement, according to that we plan. So my duty to change sec and tan in the form of what? Sin and cos. So for that reason I am going to do sec is what? 1 over cos x plus 1 divided by tan is what? Sin x over cos x. Okay guys, so now the next part is going to be here, like you know how to make denominator same here, so you'll be take the LCM cos x, right? So your cos x is going to be here, and you are going to get here 1 plus cos x whole thing divided by sin x over cos x. As you know, this cos x got cancelled, so we are going to get here practically 1 here, 1 plus, what is here, 1 plus cos x over sin x. Alright, as we know from the question, our requirement to do here, like denominator is 1 minus cos x, so once again I will prefer to do conjugate multiplication. So I will do here, this is our requirement, so I will multiply here by, look, 1 minus cos x, denominator also 1 minus cos x. So practically we are going to get here 1 plus cos x, 1 minus cos x. So as you all know, sum and difference formula, from that we are going to get here 1 minus cos square x divided by sin x over 1 minus cos x. Guys, so till here I hope you all guys understood. So 1 minus cos square x, we know like sin square x over here sin x over 1 minus cos x. So many people are confused about like sin square x, you know, we can write here sin x whole square. So don't be confused about that, this is practically same, right? So this is very important part. For that reason, one sin is going to cut from here, so you are going to get here finally sin x over 1 minus cos x. So this is your right hand side, and we already have here the things what we have to prove. So this is going to be here. Alright, so once you understood question number 4, then my duty to teach you all question number 5 and 6. So I'll clear the screen. I hope you all guys understood. Now you all have to go for question number 5. So question 5 to start, I will clear the screen. So here, see you all. Question number 5 we have here, what is that? Like cot square x minus cos square x is equal to cos square x into cot square x. Okay, once again, for identity you all knows like left hand side is always equal to right hand side. So for that reason, this whole thing is going to be equal to that. For some question we have to take left hand side to prove right hand side. Sometime from left hand side the question is going to be more complicated, so in some certain question we have to choose right hand side and we must have to prove left hand side. But in some like very complicated question, even the left hand side is not equal to right hand side. So for that reason you must have to use something like take the left hand side and prove some certain like trigonometrical equation which is related to by sine, cos or tan or cot or sec, and then the right hand side you choose and just you prove the same amount. So if both sides are equal, then is also a given identity and hence is proved. Alright, so now what I am going to do here guys, you all see here. So the practical things are here, we are going to do like look here, I am taking here left hand side. So left hand side, because from left hand side I hope the question is going to be easy and we can easily prove it. So you write here cot square x minus cos square x. Alright, you guys knows very well like cot square x in the term of sine and cos, because we are still going to prove that. So I will write here cos square x over sine square x minus cos square x. Once again I will make denominator same. So what I am going to get here, can I take cos square out? So if I will take cos square x out, so we are going to get here 1 over sine square x minus 1. So here cos square x bracket, total LCM is here sine square x. So you guys are going to get here sine square x, then 1 minus sine square x. Alright, so as we know here, like cos square x, I will write cos square x, then this things 1 minus sine square x, you know the formula. For that reason I can write here 1 minus sine square x is what term? Cos square x, because you know the first identity here sine square x plus cos square x is equal to 1. For that reason we can use that. So we can write here cos square x over sine square x. As you know, your right hand side you have to prove this cos square x minus cot square x, as I wrote here. So you can write here cos square x, and you know very well this cos square x over sine square x is called what term? Cot square x. So finally you got here cot square x times cos square x, and this is your right hand side, or hence proved, or QED. So generally what I told you, we have to choose left hand side and we are trying to prove right hand side. So this is your proved, and there is 4-5 steps you have to think. So practically you can say trigonometrical identity is a kind of lock where so many keys are possible, but which key is going to exactly fit, we have to go according to that way. So there is identity has almost like 10 to 12 formula only for plain identity. There is double angle, then how to implement a plus b, that is a different part. You all will find that video in my next part. This is maybe I am making the second video or maybe the fourth video for trigonometry. There is so many huge part. Trigonometry alone is very huge part, so I will take some more time to complete everything. By the way, you guys, I hope you all are enjoying till here, and we already have done question number 5. So now I'm going to do for question number 6. You all see here, like for question number 6, as you all are seeing here, we have to take left hand side, that is here tan x over sec x minus 1 is equal to what is here sec x plus 1 over tan x. Okay, so as I told you, mostly in every question we have to take left hand side and prove right hand side, somewhere right hand side to left hand side. Even in this question I am taking left hand side and trying to prove right hand side. Okay, even you can take right hand side and you can prove what? Left hand side. So see here guys, left hand side, right? So what we have to do here, down I need tan and up I need sec. So I will prefer to do conjugate multiplication, tan x, here say sec x minus 1. So to do conjugate multiplication, here I am using like say sec x plus, because I need to get a plus 1, and here down is also same number sec x plus 1. So as you all guys knows, here I will keep same tan x and here sec x plus 1, and whole thing divided by sum and difference formula, a minus b, a plus b is a square minus b square. For that reason is going to be sec square x minus 1. Now here if you know till here, so I will say this is going to be here a formula, as I told you, sec square x minus tan square x is 1. One very good things I will tell you all guys, to prove this kind of identity, you must have to memorize all the identities formula, like what I mentioned in the first page. You really have to know. If you are not going to learn that, you will be suffer, and there is a chance you will be not able to prove any identities. For identities, your first duty to just complete all the trigonometrical identity formula by heart. But the kids those who are appearing, this is for state board, CBSE, ICSE, and the kids those who are like not able to see their formula booklet in their exam. But if you'll be talking in respect of IB, SL, HL, so they have their data booklet or formula booklet. So over there they can see the identities formula, and they are having a certain part of the formula which they can implement and prove all the part. But the kids, those who are appearing for A-Lebel or something, still they have few part of the formula and they can also like use that. So it's not a big deal. But mostly the kids, those who are not able to see their formula, they must have to learn their formula by heart. Okay, so as we are seeing here, like we can write sec square x minus 1 is equal to tan square x. So that's you implement here. So we are going to get here, like here, like we are going to get finally tan x, and we are getting here sec x plus 1 over tan square x. Okay, so if you already have seen there, 1 tan x got cancelled. So finally we are going to get here what, sec x plus 1 divided by tan x, and this is your right hand side. You can say hence proved, or so many people say QED also. It's depend on you how you are going to implement and what you are going to say. So this is our question number 6, and I hope you all guys understood till here. I have some other more questions that is also going to help you. So this is the general idea how to use the trigonometrical identities formula to prove the trigonometrical identity. Yeah, so there is much more questions I have what I'm going to say you all, and you guys will be understand. Just see here my next page, like here 2 seconds only, like here. See, so this is another part of the question, 2 minutes, like here clear the screen, that would be better. Then I'll take like another page that will be much more clear and you all can enjoy it. Yeah, here. Okay, so what we are going to do is just like so many things, and we are going to do here like just 2 minutes. Here, question number 1. Once again, some different kind of question that is kind of easy or hard, I don't know, but yeah, we have some list of questions that is for A-Lebel, IGCSE, IB, CBSE, ISC, or even for those who are going to appear for ICSE on any kind of like IB or HL, SL or studies, whatever, all are going to help, and you all must have to enjoy. See here, basically this topic is not in IB studies course, but A-Lebel has this all, so you must have even IB, HL and SL have. So yeah, here suppose the first question number, and we are going to take here left hand side and we are going to prove right hand side. So we have in the question sec x minus tan x into sin x is equal to 1 over sec x. Okay guys, so see here sec x I am going to, because generally once again we have to do something like in that way. So sec x we can write 1 over cos x. Alright, now minus tan I can write what, sin x over cos x, and sin x I will write what is here, sin x. Okay guys, so once again we are going to get here 1, and you are seeing here this sin x, right, and this sin x, because this is over 1, so sin x into sin x is what, this combined will be sin square x. So I am going to write here 1 minus sin square x over this cos x is the denominator and it's same, so I will write here cos x. As you all know, sin square x plus what is here, sin square x plus cos square x is 1, so we can write our requirement is here cos square x as I told you on the first page. So yeah, this is here, so we are going to use in the place of that what is here, cos square x. So look here, I am going to use in the place of that here next step 1 minus sin square x is equal to cos square x over cos x. Alright, this cos x got cancelled, so we are going to get here cos x, and cos x is the reciprocal of what term, sec So we can write this 1 upon what is here sec x. So this is your right hand side. So this part is also got proved. Alright, so this is question number 1. Now I'm clearing the screen. I hope you guys are just going with me, and you are writing also these questions, and you all are enjoying that. I hope it's going to help you. If you have any problem, as you all know, my email ID prashant@gmail.com, and even my phone number. So whenever you have any kind of doubt, you can call and ask. So this is your phone number. So anytime you have any problem, you can WhatsApp to me. Whenever I have free time, I'll just reply you all if you have any problem. Okay, right. So see here, like I'm going to do now question number 2. As you all know, it's question number 2. Once again, I'm going to use left hand side. I'm going to prove right hand side. So this question looks like a bit easy, because I think this is only 2-step question by seeing the things. So here, see, I'm using left hand side. So for left hand side, you guys here, you can write here 1 plus cos x over sin x. So we can write here 1 over sin x plus cos x over what is here sin x. So 1 over sin x is going to be changed into, you know very well, cos x, and this is going to be cos over sin is cot x. So here we are going to use here like cot x. So practically you are going to get here finally what we have right hand side. So CSE, cosec x is also called CSE x plus cot x. Alright, so this is the meaning of the question, and you already got your right hand side. Okay, now finally I'm going to go on question number here 3. Question number 3 is saying to us here sec theta into sin theta divided by here tan theta plus cot theta, and we have to prove finally here sin square theta. See, so this question there is no way to take right hand side and prove left hand side, because it's more complicated. So we might have to think about here left hand side. We will take left hand side and we are going to prove right hand side. Okay guys, so here sec theta, here you have into sin theta. So we will be do here tan is what, sin theta over cos theta, and cot theta is cos theta over sin theta. Okay, the next step, we know sec theta is 1 over cos theta dot, here we have already sin theta, and nothing means we can raise ourselves 1, and denominator here we have to take like make here multiply by sin here, and here by cos to make denominator same, or you can take the LCM butterfly method, cos theta into sin theta. So sin into sin is sin square theta plus cos into cos is cos square theta. Okay guys, so see here is what we are getting, denominator part sin theta over cos theta divided by sin square cos square theta. As you all know, is the first identity is 1, and then here sin theta into cos theta. As you all know, I'll give you a tips what people generally don't know, a by b divided by c by d. So we can write here a by b times d over c, so it's going to be ad over bc. So the same thing we are going to implement here, and we are going to get sin theta over cos theta times what is here sin theta into cos theta. So this cos theta cancel, and generally we got here sin theta into sin theta, and this going to be equal to here sin square theta. And this is our requirement. As you all are seeing here, we have to prove right hand side. So this is your right hand side, and your answer, your question number 3 is proved. So this is the whole thing what you have to do. Some questions are quite long, some questions are quite easy, some questions are really hard, then you really need like 1.5 pages. So trigonometrical identities also itself is a very like good topic where people are like going to spare so much time. So in my opinion, as I told you in few minutes before, you must have to memorize all the formulas. That would be really helpful to you, right? So here like we are going to do now next part here. The next question is also going to be somehow here question number 4. So question number 4, guys, see you all here. We have to prove here once again sec theta, right, over cos theta, right, minus tan theta over cot theta, and we have to prove 1. So once again, I hope we have to take here left hand side. So left hand side, and we'll prove right hand side. Okay, so left hand side sec cos, and anyhow we have to prove 1. So you know very well here sec I can write what, 1 over cos theta over cos theta, then minus tan we can write here like tan we can write sin theta over cos theta over cot theta we can write like cos theta over sin theta. Alright guys, so what you all are seeing here, 1 over cos theta over cos theta, so this is 1, so practically is going to be 1 over cos square theta, then minus this is also, this will be move up and this will come down, so sin will multiply each other, so you are going to get sin square theta, right, and down is going to be cos square theta. So the next step, you know the denominators are same, so we are going to write here cos square theta, and here is going to be 1 minus sin square theta. So practically you know very well, even in last page I already explained, like 1 minus sin square theta is equal to what is here, tau cos square theta, and denominator also here is going to be cos square theta, so this got cancelled, cos square theta is 1. So you are seeing in the question in the 4th we have to prove like here 1. So you already have seen 1, and this is your right hand side. Alright, so after doing till here, I am going to go on question number here, like question number 6. You all see here what is the question number 6. So question number 6 is going to be here like quite easy, I hope so, but let's see. CSE square theta, that is called cosec square theta, into here tan square theta minus here minus 1 is equal to tan square theta. Okay, so once again we are going to take here left hand side, or people write LHS, up to you. So we are getting here cosec square, COSEC, don't be confused, CSE or cosec square theta meaning is same, into tan square theta minus 1. So you know very well here cosec is what, cosec is 1 over sine, so we can write here 1 over sine square theta, and tan square theta is sine square theta over cos square theta minus 1, right. So as you see here, this is up and down, sine, so this sine and sine got cancelled, so we are practically getting here 1, and here is cos square theta, so we are going to get here 1 over cos square theta, then minus 1, and this is going to be here, as you are seeing here, like 1 minus cos square theta, 1 over cos theta is sec theta, so 1 minus cos square theta is equal to sec square theta minus 1. So finally you are going to get here, as I told you, like sec square theta minus tan square theta is equal to 1. So here sec square theta minus 1 is equal to here tan square theta. So here you are seeing this is equal to this, so we come here and we can say here sec square theta minus 1 is equal to tan square theta, and you want to prove that in your question number 6 what we have. So practically it's proved here, and this is your right hand side, or you can write hence proved, as you wish, is your planning. So this is the whole thing what you have to know. Then only one question left, that is question number 5. I'm going to prove that also, and after that I hope we are going to talk about little bit what is there and how to work it out. So here you see question number 5 I'm going to do for you all, like here question number 5. So here question number 5 guys, here cos square y minus sine square y is equal to 1 minus 2 sine square y. Okay, so you have to take once again your left hand side, and this is here cos square y minus sine square y. As I told you few minutes before, we have to see our right hand side and we will see what is our requirement. According to that we take the steps which formula we have to use. You are seeing in your question you need 1 minus 2 sine square y. So I cannot change sine, no, at all. Only I have an idea to change cos, and you know the formula, first identity sine square sine square y minus plus cos square y is equal to 1. So as I need here cos square y, so cos square y is equal to 1 minus sine square y, right? So I'm going to implement here. So in the place of here cos square y, I'm going to write here 1 minus sine square y, then here also sine square y. So finally we are going to get here, as you know this both are the like term, and before that the coefficient is 1 for both, so we can write 1 minus 2 sine square y, and you see here, right? So we already got proved, because we have to prove here 1 minus sine square y, and we already got proved here 1 minus sine square y. So this is your right hand side, or you can say your QED, or whatever, hence proved, whatever you want to do. So this is the things what you have to do. And generally what I told you, trigonometrical identity is really a very important part of trigonometry. Without that you cannot solve the trigonometrical equation. So I want to talk to you all 2 minutes about this topic, like here trigonometrical identity is really important to solve like trigonometrical equation, what I'm going to make my next videos also. And this trigonometrical identity is not only in this form, there is another form also, like double angle, then a plus b. So you all can find these videos also in my next part of the video, which is going to pop up soon. Maybe it may be like, I don't know when it is, but yeah, it will. So maybe in next videos I will just explain what is the sine double angle, what is the cos double angle, and what is the tan double angle. that thing is also very useful for your C3. C3 means A-Lebel has C3, now is converted into P3. So even the kids, those who are in complete A-Lebel, not in AS-Lebel, they might have to get their help. And this is very useful for trigonometrical equations. So maybe in my next video I will solve some trigonometrical equation question. So you'll get the idea. After that, maybe I'll try to plan and make like double angle videos and everything. Okay, so I hope you all guys are understanding. If you have any problem, any kinds of doubt regarding your IB, HL, SL studies, or A-Lebel, or even CBSE ICSE, or any state kind of board, even for universities courses, those who are doing computer science or whatever, don't feel any hesitation. You can call my mobile number, or you can just contact through my email ID. I'm always available, but yeah, sometime I may not, because generally it depends how I have my class and everything. Hope you guys enjoy this class. But trigonometrical identity, I already gave you all the full ideas. So yeah, hopefully. Okay, so you all will see me in my next videos. Hopefully it is going to be soon, and basically I hope you all are enjoying. Okay, so good luck, see you all soon. Okay, have a nice evening, good luck, take care, bye bye, see you all friend next time, bye.